Hi, my name is Nick Bruton, and today we're going to be doing a spanning tree lab. So our first task in this lab is to verify that the current IP configurations on PC1 and PC2 match the IP configurations listed in the IP address table. Those are right down here for reference. So we're going to go down to PC1 and we're going to issue the IP config command. That's going to show us our current configuration. As you can see right there, all of that looks to match up with what it should be. So now we need to go over to PC2 and do the same thing. We can see that all of that information is matched up to what it should be. So it looks like our configuration is correct. And we can move on to step 2, which is to verify the connectivity by pinging from PC1 to PC2. So let's go over to PC1. We'll issue the ping command followed by the address we want to ping, which is 102. And we can see that all of our pings have gone through. We sent 5, we received 5, and it looks like there's no problems there. Our connectivity is good, so we're moving on to step 3. Step 3 wants us to configure switch 1 with the appropriate host name. So we'll go over to switch 1, go into enable mode, global configuration, and issue the host name command followed by the name that we want, which will be switch 1. And we can see that the prompt has gone from switch to switch 1. So it looks like the host name has been changed successfully, so that's good. And we're moving on to step 4. On switch 1, configure fast Ethernet ports 01, 02, and 03 as trunk ports and create VLAN 3. Well, since we have a range of 1 to 3, what we're going to do is we're just going to do the interface range command followed by the ports that we want. As you can see here, the prompt is now config interface range. So what that means is that any commands we issue to one of those ports is going to affect all of those ports. So at this point, we need to create trunks out of those ports. So our first command is going to be switch port trunk encapsulation.1q. That's going to verify that those are all 802.1q and not ISL. So next we need to do a switch port mode trunk command, and that should be good. Those should be trunking now. We're going to verify that by doing the show interfaces trunk command. As you can see, our interfaces are currently trunking and they are under the 802.1q encapsulation. So it looks like that was successful. And now we're already in global configuration, so we're going to go ahead and make the VLAN 3. And all we're going to do is issue the VLAN and the VLAN ID. And that's it. VLAN 3 should be created. It's really that simple. We're going to verify that though. I'm going to show VLAN brief command. You can see right there that it's been created. We have no ports assigned to it yet, but that's alright. We'll get to that in a little bit. And now we're moving on to step 5. Configure switch 2 with the appropriate host name, create VLAN 3, and add fast Ethernet port 04 to VLAN 3. So we need to go on over to switch 2 and change the host name just like we did with switch 1. We'll into global configuration, host name switch 2. Now we need to create the VLAN 3, and next we need to go to interface fast Ethernet 04 and assign that. And what we're going to do first is a switch port mode access command to ensure that that switch port is in the access mode. And then we're going to do a switch port access VLAN 3 command. And that's going to tell the switch port which access VLAN it belongs to. So at this point, we need to do a show VLAN brief to confirm our configuration. And you can see here, VLAN 3 has port fast Ethernet 04 assigned. So it looks like everything's good, our configuration worked, and we're moving on. On switch 2, configure fast Ethernet ports 01 and 02 as trunk ports. Alright, so in order to do that, we need to go to interface range, fast Ethernet 01 through 2, because we're doing multiple interfaces. And we're going to configure those as trunks just like we did with the other switch. by doing switch port trunk encapsulation.1q switch port mode trunk, and that should be good. Let's make sure that those are trunking. As we can see, Fast Ethernet 01 and 02 are indeed trunking, and the encapsulation is 802.1q. So it looks like we're doing good there. And we're moving on to step 7. We need to configure switch 3 with the appropriate host name, create VLAN 3, and add Fast Ethernet port 04 to VLAN 3. Alright, so we're going over to switch 3. The same thing we've been doing. Access. And we can see here that we have VLAN 3 and Fast Ethernet 04 has been assigned to it. So that's good. And we are moving on to step 8. On switch 3, configure Fast Ethernet ports 01 and 03 as trunk ports. Alright. So we need to configure Fast Ethernet 01 as a trunk. So what we're going to do is do a switch port trunk encapsulation.1q switch port mode. Almost missed that. Trunk. Then we need to do interface Fast Ethernet 03. Switch port mode trunk. Alright, let's go ahead and verify that. I always love to verify just to be sure. And oops, wrong one. Do the show interfaces trunk command. And we can see here that the Fast Ethernet 01 and 03 are trunking, and they are both 802.1q encapsulation. So it looks like we're good. Moving on to the final step of task 1, and that's to verify the configuration by pinging from PC1 to PC2. So I'll just hit the up arrow because we've already done that previously. I'll make sure we didn't break anything here. And it looks like everything's good, so our configurations didn't destroy the network. So looks like we're good there. Now we're moving on to task 2. On task 2, on router 1, we need to configure the appropriate host name. So we're going to go over to router 1. And this is really the same thing as a switch. We'll just go to global configuration, to the host name command, and name it router 1. For the real world, you'll probably want to name that something a little bit more specific. Router 1's a little bit generic. You want people to know which router they're on if they telnet in or whatever, so definitely something to keep in mind. But for a lab, this is fun. Alright, so on router 1, configure Fast Ethernet 00 interface with the appropriate IP address and subnet. Refer to the IP address table, configure the interface with 802.1q encapsulation for VLAN 3, and enable the interface. So the first thing we want to do, just to be sure that there's no previous configurations on here, is to do a show IP interface brief. And we can see here Fast Ethernet 00, no IP address is assigned, and it's administratively down and line protocols down. Administratively down means it's issued a shutdown command. That's default on a router for security purposes, so definitely not something we don't expect to see. So we're going to go into that interface. We're going to assign an IP address based on the table down here. It's 192.168.100.1, and the subnet mask is 255.255.255.0. Alright, and at this point we need to do the encapsulation .1q and VLAN to encapsulate VLAN 3. And now, finally, we issue the no shutdown command. As you can see, the interface changed state to up, line protocol is up. So it looks like we're doing good there, but we're going to verify that just to be sure that everything looks good. And there we are, fast Ethernet 00, IP address looks good, status is up, line protocol is up. So it looks like everything's good there. And we're moving on to the next step of task 2, which is to verify the configuration by pinging from the router 1 to PC1 and PC2. So we're going to go down here and do a ping. You can do a ping from a router by issuing the ping command and the address of PC1, which is 101. It looks like we have a 100% success rate, so that's great. And now we do PC2. And again, we have a 100% success rate, so that means we can definitely verify that our path from PC1 up to router 1 and PC2 to router 1 is working good. So that's great. At this point, we're going on to task 3. And on switch 3, we need to set the priority for VLAN 3 to 0 to ensure that it is the root bridge. So let's go over to switch 3. And we're going to global configuration. We're going to issue the spanning tree VLAN followed by the VLAN ID priority 0. The way priority works, the higher priority, the less chance the switch has of becoming the root bridge. The root bridge is basically the king of the hill. Basically, you don't want an old switch to become your root. You want a powerful switch, a switch that's going to be doing a lot of work, because that's what the root bridge does. So by setting the priority, we basically to 0, we basically ensure that it will be the root and that no other switch on the network is going to take its place. So that's what that does. And at this point, we need to issue the show spanning tree VLAN 3 command. And we can see here that the root bid has a priority of 0. The MAC address right there. We can see the timers. Those are default timers: 2-second hello, 10-second max age, which is 10 times the hello, forward delay is 15 seconds. This is our bridge ID. This is the bid from the switch that we're currently on, and we can see that it has a priority. It's basically the same thing as the root right here, and that's because if you'll notice here, this bridge is the root. It's basically telling you that you're on the root bridge. So if we were to go to a different switch and say go to switch 2 and verify, you can see here the root bridge is the same as on switch 1, the root bid, but right here the switch that we're on, this is its bid, and the priority is a lot different. The MAC address is different, and there's no root message. This is a good way to tell who the root bridge is. You can see that our MAC address is different. You can see that we have a cost of 19 to reach the root. So that's one good way to tell. And looks like the next step, what is the MAC address for the root? And there's the MAC address right there. What spanning tree protocol is being used on switches. And we can see right up here, spanning tree enabled protocol PVST. That means per VLAN spanning tree. So what that means is that each VLAN on our switch calculates the spanning tree out differently depending on the configuration for that VLAN. So if we were in VLAN, say we made a VLAN 2 and we set the priorities differently, this switch 2 might become the root bridge, and switch 1 may not be the root, but it may be the root for VLAN 3. So right now we know that switch 1 is the root. We set the priority. We know the MAC address, so we know that. The priority of the root bridge, we know that the priority of the root is 0. And what port on the device is in blocking state. So on a root bridge, there's no ports in blocking state. They're all designated ports, which means they're all forwarding. On a non-root bridge, like on switch 2, we can see our states right here. And the only one in a blocking state right now is Fast Ethernet 02. And it's in a blocking state to prevent routing loop, or switching loops. That's a good thing. We don't want switching loops. They'll be a nightmare. It could cause the whole network to go down. So that's really the whole point of spanning tree, is to prevent switching loops. We don't want packets going around and around, creating broadcast storms, all that. So anyway, I hope this video has been informative. Thank you for watching, and see you later.